right, so it's recording now. All right, so let's go ahead and take a look at intrusion detection. So let's sort of recap. Let's open a new terminal. Right, so remember that you have to install the tool, right? And that's just something like sudo. You have to do sudo apt-get install. I already installed it, so, but do something like sudo apt-get install. Sudo apt-get install snort. Then it's going to ask you a few questions, right? So click OK on those. And then, once you do this, it'll install. So that's, so I'm not, again, I don't want to run it, but that would be the command. Then after that, you can just start up. Now remember that the scenario here is that, and let me go to the whiteboard for this. In a perfect scenario, you would have 3 VMs, right? You'd have 3 VMs. Now, of course, you don't need 3 VMs, but in a perfect scenario, you would have something like this, and you tap into the line, and this is snort. Remember that physically you would need a tap, but because we use VMware, which basically acts as a hub, you just have to set this into promiscuous mode, right? And we saw the command for that a few weeks ago. And then here you would have, a client and a server, and they're doing something. But you can also think, you have an attacker. You have an attacker. And so the attacker then will spoof packets, right? So the packets are sent. And then, it doesn't matter where they go, but the intrusion detection system, because it's signature-based, remember, signature-based, it would capture the packets, right? And if it works, it'll trigger an alert, right? It'll trigger an alert. So in this case, for instance, you're reverse engineering. So you're looking at, the signatures that are in snort, right? The files, the rules, and you're going to try to trigger one of those, right? By triggering an alert, and that's how you know you were successful. But it has to be a very much an exact match, and that's really what makes it a little bit challenging. So if we take a look, then that that's sort of the scenario. So the machine, the snort machine, right? That would be the snort machine. On the snort machine, you have to run the command something like snort -q uppercase A console and then -I, so ENS33 in this case, which is the interface of your VMs, and then -C, the configuration file, which is, you don't really have to make many changes to this, etc snort.config, right? So that's basically the file. So permission denied. Okay, why? Sudo, right? Doesn't need to grab the interface. And there you can see the file is basically just listening there, right? So it's just listening there. Because this is a hub environment, right? Then I can just, let's say I'm going to start up a terminal, and I can just ping anything, right? So I'm going to ping google.com, right? I'm pinging there. You see that? And then when I try to go to my snort device, it should be, I think I have 2 of them. You can see that what's happening there, this is the snort device. You can see it's changing, and it's just picking up those pings, okay? It's just picking up those pings. So actually, I have another one. Okay, so the pinging is still going on, and I have an alert here. So basically, when it's a sniffer, right? So snort, in its basic sense, it's a sniffer. All of these are the pings that are being sent by myself. However, that doesn't really accomplish much. Here it's just a sniffer. So now what we want to do is we want to take a look at it as it detects some kind of an alert. Okay, so I'm going to leave it running, but I'm going to switch over. I'm going to kill that ping wherever I had it. Just here. Right, so I'm going to kill this ping, exit terminal. I think I have another ping running. All right, no, this one's fine. So then on this terminal now, so the key question is, now if we go back to snort, the IDS, we take a look at it, you can see the pinging kind of stop also on it, right? Every now and then, like if I open, for instance, a browser, let's say that I open a browser, or there's a few applications running in the background that might send network information. So every now and then, it's going to pick up that information. However, what I want is I want to be able to detect an attack. And an attack, as we defined it, was defined by signatures, right? So for instance, if I go then to another terminal, let's say this one, remember what I said, that all the attacks are in a specific location in snort itself, right? So I'm gonna go to right. So I'm gonna navigate into snort. So notice I am in home seed. I'm gonna navigate to etc, right? That folder, and then I'm going to navigate to snort itself. So snort, I'm in snort, and then I'm going to navigate into the rules folder. So you can see that there. I am in rules, and now I can do ls-l, and you can see, or actually I should just do ls here. So I'm going to do ls, and you can see I've got basically the different files, right? So I have, for instance, here exploit.rules, right? And I've got other ones that I can look up. And so, for instance, DDoS rules is really the one that we want to kind of take a look at. So, for instance, I'm going to first just do cat DDoS.rules, and you can see it shows me all of the alerts. But there's really a lot of alerts here, right? So what I said is that for this example, you can try, what were the three ones? TFN, let me clear here. Clear, so TFN, there's also TFN2K, so TFN2K, and the last one, Trin00, right? So these three alerts, I already gave you how to write the code for them, right? And what you want to do is you want to trigger these alerts. So that basically means that these three attacks, which are DDoS attacks, have signatures for them, right? So I want to look at the signature. So what I can do is I can do cat DDoS.rules, just like that. And, I just want to grab some of the ones, I don't, because I get a lot of information. So what I can do is I can just pipe through grep. And let's say I want to take a look at Trin00, right? So if I do that, now I have all my individual. Notice that when you look in the file, there's actually several versions of Trin00 is not just one of them. So I actually just gave you let's say the signature for just one version of Trin 00. So I gave you, I think I gave you the one for Pong, okay? Or so the one that says UDP 31335 with a raw load of Pong, right? That's the one that I gave you, but there's actually several versions of Trin, right? So DDoS Trin 00, master to daemon, but this one is DDoS Trin 00, attacker to master, and so on. So there's another one, DDoS Trin 00, attacker to master default password. So you can see there's several versions of this. And the one that I provided in the example, I believe is this one, that alert, right? So Trin 00 daemon. So notice that the alert that should be rendered is this one, right? So you should see something like that. DDoS, Trin 00, daemon to master, Pong, message detected, where the content of it is itself Pong, right? So then you should see, so that's the alert. So, you know, I gave you 3 problems that are already, you know, I provided the sample code. So for DDoS, for scans, and for exploits. And then you guys have to create your own. So I would like you to at least be creative in one of those alerts. But let's just, you know, take a quick look at this, you know. So to trigger the alert, remember all you have to do is, you know, open a terminal, right? And let's say on the desktop, I'm going to go to ITS 454. And I don't have any files here, so I'm going to just do nano. And I'm going to call this ddos.py. So I go in here, so from Scapy, scapy.all, import all, right? So that, you know, that's pretty much what we've been doing all semester, just writing the same code. Create a function, DDoS, you know, call it test or whatever. And this can take some parameters, so source, destination, these are just the IPs. Now, you don't have to look at very complex alerts or rules or signatures. Pick anything, you know, a simple one, right? So here I do the count, source and destination, and the interface, basically. So now I'm going to do in here 1, 2, 3, 4. I'm going to create the packet. So the packet will be, you know, IP, where I just provide source equals source, oops, lowercase, comma, destination equal destination, interface, and count. Okay, so that's basically the IP header. Oh, sorry, what am I doing? So just the source and destination. Then concatenate, just like we've done before. This takes ICMP, okay? And you're going to look at, and that protocol you could check out in where we did Trin 00. Right, so this one's UDP. This one's UDP, TCP. Okay, so then try UDP there. All right, so this is how you would try to figure it out, right? So in this case, I'm going to try UDP. I'm going to go back to my code. Okay, so let's do, yeah, so sorry, so it should be UDP here because we saw it in the alert. So that's, you know, that's really all I'm asking you to do is kind of figure these things out by looking at the alerts, kind of reverse engineer them. So in this case, the destination port is what? So we go back, you know, we kind of go back, have to go back and forth. Destination port 31335. Right, and as I said, I gave you these. So okay, so then here 31335. Okay, and then again / and then the raw open parentheses, close parentheses, load, right? And then load equal, well, I'm just going to type it. It's actually Pong, but we're going to go back and look at the signature. So there's Pong. That's the load of it. So if I scroll back, we can see that. Actually, for this to be a little bit better, let me just do the following. I'm going to do A, B, and then this is going to be C. And so now we're just going to concatenate these together. So this is going to be packet equal A, B, C. You see that? So that's our approach. Okay, so all right, A, B, C, we've got the packet there. So now what do we want to do? We want to, we've created the packet. So then the next step, we want to send it, right? So we're just going to do send. And what do I send? I send the packet. I'm going to specify the interface equal to the interface that I'm going to designate, and then the count, how many packets I'm going to send. So that, that's pretty much all you have to do. Then the source can be anything, a spoof packet, 1, 2, 3, 4, right? It's a spoof packet, really. The destination also, would be something where it's going. If it's listening like in a hub in promiscuous mode and you're tapped into the network, also be an issue. Let's just do that. You can also target directly to the snort machine if you want. That's perfectly fine. And then you're going to set up the interface. So I think it should be ENS33. Okay. Let me do here. So we got interface. We're going to set up the count to be equal to 1. But if you want to send more packets, you can do that. And then you just call the function. So DDoS test. Right? And now you do source, destination, interface, and the count. All right. So this is basically, the goal is to send out that packet in the network and hopefully trigger that alert. So if I'm just going to save this, Control X, Y, I'm going to go back to this file, right? And if we have everything correct for this signature, then we should get DDoS trin 00. Okay, so that should be the approach. Okay, so that's our approach. So in the other aspect of this is that we have the snort down here, right? So this is where we need to see that alert happen. So right now, snort is just listening on the network. I'm going to go ahead and run the code. Okay, so now DDoS, right? So sudo python run it. Okay, I have a typo there. so let me see. I have interface here, source destination, interface, count. Let's do that. Try spy. All right, I may not have Scapy installed on this. Float is required. All right, where? Line 15. Okay.
I got a shiny drop.
So just use, okay, so use Python 3. All right. Okay, so let me go back to the code. User bin Python 3. All right. Nope. No module name Scapy. So I have another one here. I have this, let me switch over to 1804 here. Okay, so this is another VM. So let's see, I'm gonna open up the terminal here. Python So this is 2 as well by default. So let me go back here. All right, so it's something to do with the version, I think. Go back here. Switch. Okay, so back to the code. All right, so then so the library works. There's some. What is this here? But when I ran this, it said that Python 3 didn't have Scapy. So it's not installed in the Python 3 environment. How did you use the CVM to launch the attacks on this?
I'm using the I'm using this I'm using the 16 one as the attacker,
Yeah.
and they're running Python, and then I have the 21 being the server, and it works for me.
Well, the snort, yeah, but my issue is that I'm having trouble with getting Scapy to run here. Because I can't generate the, see when I run this, well, with the sudo, it says float required and some kind of an error in the library. So I don't believe I have.
It's weird because it works. It's working for me.
With the same VM?
Yeah, I'm using the same exact VM.
And your code looks like mine?
Let me see the code.
Yeah.
I didn't do the bin bash part.
Yeah, this
the,
I only added this later.
Let me see my DDoS one.
So I don't know what I'm missing here. So from scappy.ol import asterisk. Here's the function
Oh,
DDoS.
wait. Maybe your count isn't supposed to be a 1.0?
I changed that
know.
actually.
I didn't do count or the interface. I just had the source and destination for mine.
Basically here. So you didn't have these two.
No, I just sent the packet.
Yeah. Let me leave these out. I'm gonna try it again. Oh, there we go. All right, so this version, for whatever reason, is so thanks. So this version is I don't know, some issue there. All right, so we modify the code now, right? So we have from scappy.ol import asterisk. We have the function DDoS test, right? And by default, we don't need the interface, so we can take it out actually. The count, that one's useful. So let me actually see if I can just leave the count in there because that could be useful. So count equal count. Let's see if that takes. X, Y. All right, so that seems to be working. So the use of that is that if you change the count to 2, you can send 2 packets. All right, so Control X, Y, run it. Oops. And there you go. I sent 2 packets now. So now the trick is, did I trigger the alert on the IDS? Okay, so we need to go back to, this is snort, correct? So what do you guys think? Did I trigger the alert or not?
Yeah, you did, because it even says it was a Pong, the DDoS Trin Pong.
It did, right? Exactly. So you can see that there. There's somebody waiting. Hold on, give me a sec. There's a couple of students waiting in the waiting room. All right, so they should be in now. So yes, so exactly like Joey says, you can see here that it triggered the alert because trin 00 is right there. And that's it. That's the basic idea. So if we run the other ones, like if we want to run TFN2K, what do we have to do? Well, now we have the code, so it should be easier now. We just have to go back here. We go to nano, and we are going to just say, let's say we try TFN. So for TFN, it's an ICMP packet. How do we know that? We need to go back to the alerts, right? So I'm going to do this. You guys should be seeing this here. Okay, so we're going to run, but instead of grepping TFN or trin, we're going to grep TFN. So I'm going to do TFN basically. Like that. And now I can see all the alerts in that file related to TFN, and there actually aren't that many. If you look, so we have, they're all ICMP though. You can see here, I take a look at the first one, TFN probe maybe. So TFN probe is the message. You can see that there, TFN probe. This one has a an ID, ICMP ID. You can see that there of 678, and the content of it is 1234. Okay, so that's the packet that we want to launch, and if we do that successfully, we get TFN probe. So I'm going to go ahead to the script, and I'm going to modify this. All I have to do is change this one to ICMP. ICMP. I'm going to change the now here there's instead of destination port, there's an ID of 8, or sorry, ID of 678. And there is also a type equal to 8. Okay, and where are those? Again, we go back to the alerts. So this is TFN, so the ID is there and the type is there, type 8, you see that. Okay, and so we want to basically trigger this one. Also, it has content equal to 1234. So I'm going to go back to here. All right, and I'm going to, instead of Pong, it's going to be load 1, 2, 3, 4. All right, now once I do this, I really just need to send out one packet. You don't need two. So I'm going to do 1, Control X, Y. Now I'm going to go back to the snort machine, right? Currently, the last attack received was DDoS trin 00. You guys can see that. Instead, now we want to trigger the other one, right? So we want to trigger TFN. So I'm going to go ahead and run the code now from here. So clear. And I'm just going to do this. And one packet was sent out, right? So now we need to take a look at what it looks like. So I need to go to snort. And what about here? Did it work? So it did work, right? Because you can see here in the output, right? So you can see here in the output this, right? DDoS TFN probe, the exact alert that we were discussing, right? So that's, you know, and then if we want to repeat the same process again, you would do it with the third one. So that one I'm not going to look up in the alerts, but because I think you get the idea, but we can just quickly look at it. So in this case, I gave you the packet. It is UDP port for this one. This one is an ICMP as well, and it's only type 0. Type 0, right? And doesn't have any other in the signature, and the payload will be A's. I think it's 10 A's. So it's 10 A's. Okay. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just going to do 9. Let's see what happens. So I'm going to do Control X, Y. Right. I'm going to go back to snort just to take a look at it really quick. Right. It's still kind of waiting there at DDoS TFN. I can do this. You can see there's nothing there. Now I'm going to try to run it with 9. Let's see what happens. Sent out a packet. Go back to snort. You can see it generated this ICMP. You know, some traffic in the network was generated, but not the alert, because it has to be an exact match. Okay, so now if I go back, I'm going to add that extra A. It's got 10 A's. Oops. Right, we got a 10th A there. So Control X, Y. Run it again. goes out into the network. The intrusion detection system this time around detected TFN2K. I usually like to put IP addresses like 123.4.11111 so that I know that that's my traffic and not something else. Does this make sense, guys? This is, basically the scenario, and that's, problem 1. Then you have to do problem 2, which is the exploits, problem 3, which is the scanning, and then and then you have to come up with a couple more. So let's for instance think about the one that's scanning, right? So that would be problem 3. So for scanning, we look at for scanning, we are going to look at we want 2 alerts, right? We want CyberCop or Amanda. I just, those have, like easy names to spot. So we need to go for this one. What's the first thing we need to figure out? What is the name of the file that contains these rules? So we need to find that out, right? So we go to the terminal here. Okay, and LS, so there should be a scan rules. So there it is. So I'm going to do then cat scan dot rules, right? And I'm going to pipe to grep. And this time around, I want to find CyberCop. So I'm going to say CyberCop. And there we go. I found all the CyberCops in that file, basically. And so I can see, okay, I look at this one. Okay, and that CyberCop is TCP. There's another one, TCP. There's this one, UDP. So alert UDP. Destination port is 7. You can see that here. 7. It's called a CyberCop UDP bomb. Okay, you identify that. And conveniently, below the content also says the word CyberCop. So then we can kind of just take a look at that to try to figure it out, right? So we can, all right, so we can go ahead. This is one. I'm only going to do one of these 2. So again, we go back. We can go back to we can go back to we need to go back to the script. So here it is. I'm going to open up this. I'm just going to open up the same script since I know this one works. This attack is a UDP one. Okay, so first thing I'm going to change is this ICMP, right? So I can piece together my packet. So UDP, and then we set that the destination port was 7. So then I'm going to go in here, dport lowercase 7. Okay, so that's done. What else? And it also says that the load is actually CyberCop. So now CyberCop, and that should be it, right? So if I do Control X, Y, okay, and I'm going to run it, sent out a packet. Now I can check snort. Okay. And this one also worked. I know it's my packets 1, 2, 3, 4, right? Went to 1117, and you can see it scans CyberCop UDP bomb, and you can see that there. Any questions?
No questions.
No questions? All right, so that's basically it. That's sort of two of them. Then there's the exploits one. Has anyone gotten the exploit to work? Anyone? Joey? Josh?
Yeah, I'm trying. Oh yeah, I found it. Yeah, I got that one.
You got the exploits to work?
Yeah.
Did you got it to work the way that I gave it to you with the hex? You know which one I mean, right? The one that's got all the hexadecimal values?
Yeah, I did a hex one, but I ended up doing I ended up doing a no-op one. I did
You did a different one?
yeah, it doesn't
So,
oh there's
but,
I did the overflow no-op.
but my question is it from the file called exploit.rules?
Yeah, it is. It's from exploits.
All right, so let me do that. So let's go to the files, right? So we're here. And so ls, and then exploit this one, right? Exploit.rules. So we
Yeah.
can take a look at cat exploit.rules, right? And so these are the hexadecimal ones. So if you don't know what these are, so you just have to remember your ITS 450 class, right? So in ITS 450, when you looked at buffer overflows and those kinds of things, you always had to inject shellcode. And so that's what these are. And I gave, I think, so you used this one, Joey, this one, the NOAA?
Yeah, that one. It was easier for me to write down.
So now the alert that was triggered, was it NOAA like this?
Yeah, it was that one triggered. It's just the one that you gave us, I couldn't find a list and that one was right in front of me, so I kind of just chose that one.
Okay, so let's take a look at that one. So I'm gonna do pipe and then grep. No, it was uppercase, I think. No up like that, right? So here they are. There's only one actually, right? If you guys see, this is the command that I ran just for that rule. I grep it. And so was it TCP destination port 22? And then the content was 90s, Joey?
Let me see. So the code, wait, which one? Oh, here it is. So it was TCP, the destination port, so the server port was 22.
Right.
And the load, I'm not exactly sure how it reads, but I think it means that the load has to contain a bunch of 90s in some order.
What are these 90s, by the way? What is this usually called?
That's the NOP sled. It's just a bunch of no operations.
Yeah, no op. So remember, we learned that in 450. So if you think about it, then this is the one that we can try to craft, right? So I can try to craft this one, and this is from the exploits file, right? So if you guys are having trouble, so let's try to do this one. So I have snort running. How many no-ops? First of all, there's 1, 2, 3.
I think it's 15.
4, 15. Okay, so
I think so.
Yeah, so let's go with that. So we can go to the code, right? And this would be one of the exploit ones. So it's TCP. I remember that. TCP. Notice we're just crafting it. We found an alert. It's not even one that I provided, right? We found an alert. IP, TCP destination port, and now this, right? And so hexadecimal, is this how you coded it, Joey?
Yeah, that's how I did it.
Cool. So consistent with what I gave you guys. So then I can do X90. X90, that's 4. X90. So I'm just going to move this down. And then so I have 1, 2, 3, 4, 5 there. 6, 7, 8, 9, 10, 11, 12, 13, 14, and hopefully 15, right? So that's 15 no-ops in the NOP sled. Now we can go back over here, all right? Now, everything else should be the same as I saw, TCP, destination port 22, and 15 no-ops in the load. So now I'm going to run it. Okay, one packet sent out. Let's remember in the file, the message should say exploit SSH CRC32 overflow no-op, right? So if we were lucky, we will have this as an alert in snort itself. So we can go back to snort. And so we don't have it here. Do you have it? Did you get it? You got it on your end, correct?
Yeah, I think, I don't know, there's something about it I had to play with. I think either it needs more than 15 hex, or it needs to just be 90s and not hex. It
Okay,
was one or
just
the
the
other.
90s. So, all right, we'll try
It
that.
was something like that.
Yeah,
Because I think that reads something special.
Yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's actually 16 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's try that first. That's what I would do, right? So, you gotta play with it. So there should be, let's break this up again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to try one more. Okay. And then I'm going to make this like that. So let's just see what happens. Okay, so you would run it, you would modify it based on the alert that you looked at. And we want to go back here. Okay, so it's still not triggering. Okay, so there's still something wrong with it. So let's think about it then. So there's something in there's got to be something that we're not doing right in the exploit itself. So let's go back again to the alerts themselves. Okay, so the no-op flow to server. Just going to try to copy this as is. So copy, go here. I'm going to call this X. Okay, gonna do that. Remove a single quote. Okay, and now in here, I'm going to assign X. Let's see what happens there. All right, so that is, let's call it hex actually. Or X this one. All right, so this should have all the information in there. Sent out a packet. All right, and that one, so it does not want to detect that exploit. So Joey, you said you just added more and it worked for you then?
Actually, looking back, that is the one I haven't gotten to work yet.
Oh, you didn't get this one to work. Okay.
No,
So there's
I got to
something-
that part, but there's something with it.
Yeah. So let me do. So it's got to be something like this, that we can take the string and convert it to hex in Python. I don't know that that's a function in Python. Let me look up a function. If not, we'll have to work on this one to try to figure it out. So, Python hex. So I want to convert, let's say, string to hex. Convert Python. Convert string to hex. So let's just try it. Let's try this function, see if it works. Okay, so I didn't like that. All right, so that doesn't work. All right, so there's definitely something going on with these hexadecimal values. So I'm gonna have to check what it might be. If I look at other rules, let's try to find something easier that can help me. This has a lot of alerts. Okay, so here is the file. Okay, so this proprietary rules. Rules contained in this file are the. Okay. So here's an alert. The content is bin.sh. You see this one? This one is called overflow bin, and this is a. Okay, so this is a good way to test this, right? So if we want to know if the issue is with the exploits, with actually this encoding, a good way to test is to look at this one. So this is still from the exploits.rules file, but it is actually the content seems to be bin.sh, okay, which makes sense. And then it's TCP destination port 22, and I'm not seeing any other fields here. All of these just have to do with like the references. So let's try this alert, right? How would we do that? We want to trigger exploit CRC32 bin.sh. All right, so I'm going to go to the code. So where's my code here? Yeah, so I'm going to go to this code. I'm gonna just comment this out for now. We'll hopefully come back. It is a TCP and destination port already, but the load will be just bin.sh, hopefully. So then we can do X. In here we can say bin.sh, right? So that's the shell. So again, we can confirm that just by looking again at the alert. So yeah, /bin/sh, that's the content, destination port 22, TCP. And it's an overflow attack, so it's CRC32. So let's try that one. So we can Control X, Y, clear, sent out a packet. So now I'm gonna test this in, Snort. You can see scans were here before, but actually there's nothing here, right? It's the miscellaneous and this miscellaneous. So it didn't trigger that. That actually tells me that it's not a problem with the payload, right? Because this one didn't have any shell. So why are exploits not working? Let me send that again. I'm gonna do a massive attack on this. Just to rule out also that this requires, you know, a lot of data. So I'm gonna run this 100 times. Okay. So Control X. Right, I sent out 100 packets. This is the, so it's capturing bad traffic, that it's sending that, but it's not triggering that alert for whatever reason. The last one was the scans. So you can see that, you can see here where it says 1, 2, 3, 4, and then 1, 1, 1, 1. It's definitely capturing some packets, but it just it says miscellaneous source port 20 to less than 1024, classification, potentially bad traffic, priority 2 for the alert, but it did not recognize it as an exploit attack. Which was our intention. So if I look at it, I don't think I'm missing any other fields. TCP, external net, home net, to any port 22. Oh, wait a minute. There's some flags, right? Do you guys see this? There's actually some parameters here, additional parameters. So that might be it. This one has where it says flow to server, and it has to be an established, I think. So this also would need to be in the packet. Okay. So that might account for the problem. I was just hoping for one that was really easy. So we got to figure out how to encode that in a SCAPI packet, right? So the flow flow, what is it? Flow to server and established. Okay, so that's the next step. I mean, that's if you want to try to figure this out. That would have to be the next step to try. Okay, so flow to server. Yeah, so that might be a little bit harder to put in. Okay, so we'll have to keep working on that exploit one. I'm not. I'll have to think about it. I'm not seeing the. Can't remember if we saw something related to established. So that's probably in the TCP header, right? It's a flag. Then how do you encode that? So it would have to be, I want to say here, right, in the TCP. So you need to look up then SCAPI TCP values. TCP flags maybe. Right, so we can try. So apparently there's something called flags like this, flags equal, and then you can, probably try a parameter there. So the flags might be, Yeah, so I don't know if this, but yeah, so like flags S. So that's something like that. And that allows you to start constructing that packet a bit further. We can just try that. Let me actually change that because I know 111 is actually a real thing. So let me change that. I also don't need to send. Just going to send out 10 packets. Okay, so it sent out 10 packets there. So now let's go. All right, so this is still snort. Potentially bad traffic, potentially miscellaneous source. Potentially bad traffic, miscellaneous source. Right, so I'm not seeing that particular alert being triggered. So we just have, that's something that we'll have to circle back to. But we want to figure out how to trigger the exploits, right? So it's got to be something that we're missing. Okay, so let's try a couple other ones. So we know that at least scans worked. We know that DDoS worked. So let's try something else. So let's see if we can't. I'm going to CP this code, DDoS.py, and I'm going to create general.py. So now let me actually clear this. All right, so we're going to try something else here. Let's say that we just want to trigger so let's look, let's see in the ICMP file. So let's go to the ICMP file, which is here, right? Let's do clear. So again, let's do, I think we're in the right place. Yeah, so let's do ls. And there should be an ICMP. Yeah, there it is. So ICMP rules, there it is. So let's take a look at that one. I'm going to do cat ICMP.rules pipe grep, and let's try so large ICMP. Okay, so that didn't work. Let's try ICMP. All right, so there's a few in here with ICMP message. Okay, so these are the rules. They're bad ICMP traffic, basically, right? And really, all they are is, if we look at them, they're ICMP. The message is ICMP with a type 8, right? So it seems like it's just type 8, and the content is this, okay? Or this one that has all this content. So this one, ICMP, L3 retriever ping, I-code, I-type, content. Okay. Okay, so we can could potentially try one of those, see if we get lucky, right? So we need this. I'm going to copy that. Paste. All right, so this is content. So I'm just going to use this as is. Move it there. And then it's going to be an ICMP, so that I can change here. ICMP. The ports don't matter, so we can get rid of that. And if we do it right, we should trigger ICMP L3 retriever ping. Now there's these I codes, right? So there seems to be code which is 0, and there is also type, which is equal to 8. So this is probably without. Do you guys see this? So in all likelihood, okay, like that. Mm-hmm. We're gonna change this to get rid of that. And then this should be content. Okay. So let's see. Okay, so let's try that. Oh, that's the wrong one. It's pretty slow at sending this. Okay. Okay, so here, oh, there it is. Do you guys see the alert? Okay, so that is basically, you can consider that, that's the idea, right? So that's another rule. So obviously we're still having issues with the exploits one, but this is another family of attacks because this came from the ICMP file. Are there any questions so far, guys?
No questions.
Make sense? All right, so that is So I think that should be enough, right? So for you to get the basic idea of it. So we've done, so in summary, we've done denial of service. We did scans, and we've done ICMP. So that's 3 families. We're still short the exploits one. And, you guys can try on, let me know if anybody figures out, what the issue might be. I'll keep thinking about it. And then you still need to create a rule on your own, one more rule. So that was just an example of one. Now, another thing you could do that is actually quite interesting to do sometimes is to create your own rule and then trigger your own rule. So that basically means you kind of have to copy one of the alerts, right? One of the alerts that works, and then just change it, okay? So add it to so for instance, let's say we go, obviously the simplest thing when you start doing this is to go, let's say, to the DOS one, right? So let's go to the denial of service one, which is the one we know kind of works really well. Let's go here. All right, and so in the DDoS, so now we can look at the permissions. So these are root owned, so that means you're going to need sudo privileges. But let's say you're going to go into the DDoS.rules, right? You've opened this file now, okay? And so what you want to do is you want to write an effective. So you want to go in here and maybe write your own alert, right? Just like you have these alerts here, okay? You just want to add your own and see if you can trigger it. So the first thing that you would do, obviously, you can write this as complex as you want, right? So you can write this really as complex as you want. So let's see. Let's take a look at this one, 3135. So this is UDP 31335. And the message says DDoS trend 00 Pong, whatever, right? So content and all of this. So basically this one then is the one that you could copy. So you could copy this. Need to, oops, did I mean? So you will need to copy that rule. Oops. Hold on. So you want to try to copy this rule and maybe insert it here, okay? Okay, so you can get rid of this one. And so alert UDP, external net any 3135, and then you have to copy the rest. Okay. where were we? Yeah, we got as far as there. This is getting pretty complex. Okay. Okay, so that's the whole thing. See if I can copy it like this. Copy. Get rid of this. All right, so there is what we just added. Then we want to put this back the way we found it, like that. Oh, did I delete? I need to do that. Okay. What I'm going to do is just copy this again. Okay, so there is the two. One is the original, one is the new one. So just do that. Do that. Do that, right? So this, hopefully if I did this correct, still back the way it should be. So alert UDP 31 message DDoS trin 00 detected content reference C class type. Okay, so I think it's fine. Now this is the one then that you're going to now make it your own, right? So for instance, you're just going to say, you know, my own, you know, and mine, you know, PNW DDoS, right? You do that. And then you're going to change a few things about it. So for instance, we're going to say still UDP, but, you know, 31, let's just say all three. So 5, you know, there. And then here, just put in, you know, March. Okay. So now you've created this new alert, right? You've added the alert into your own environment. So we want to trigger this one. Okay. So I'm going to go over here. Okay. And then move this up. So now I just want to make sure that everything is correct syntax wise. So alert UDP, all threes. The message says my own PNW DDoS trin 00. Message detected. The content will say March. And then reference ArchNIDS 187, class type SSID, Rev3. Okay, so everything looks correct. So now I'm going to save this file. Okay, hopefully it's saved. I probably should start, I should probably start the NIDS again, right? So I should start snort again just in case it needs to reload the files. Okay, so it's listening. And then I'm going to go into the code general one. It was a UDP with a destination port of 5 threes. You see that? What else did we change? We changed this to March, right? So that should be the only thing. Okay, so now I'm going to try it. Control X, Y. Snort is actually running, right? So that's the one. So if I'm successful with this, I should get, so I run it. Okay, it's still taking its time. Okay, now we can take a look at Snort itself. Did it work? It did, right? Because it generates this alert, which is the alert you crafted in there. My own PNW DDoS. You guys see that? All right, so in summary, let's go ahead. In summary here, we saw examples of, working examples of scan. Also example of DDoS. We saw an example of ICMP. We're still, exploit is still not working. So we have to take a look at that. Okay, so take a look at that maybe. Email me if you figure out something before me. And then here, the fifth one, you know, you still need to craft this, all right, on your own. But I also did show you, you know, how to create your own. So create a very simple way, but at least, you know, we took an alert, modified it a little bit, triggered it, and then we were able to see our own message being displayed. Create our own, right? So this is for the IDS. All right, so this basically is, hopefully this will help you with the lab. On Thursday, if you have any questions, just ask. Also, so we're still trying to figure out that, you know, that exploits one. So I definitely want to see it working, and I'd like to understand actually why it's not working. So that's really the only thing that's kind of still outstanding. All right, so we can stop here for today. Also on Thursday, we might start looking at firewall things. Just depends on your questions. Remember, this homework assignment is due Thursday night. All right, so I'll stay a few minutes if you have any questions. Otherwise, we'll stop here for today, and I'll see you Thursday.
All right, Professor.
You have a question?
Yeah, in the lab, we don't have to create our rule, right?
No, you don't. I was just showing you that that's another possibility, right? That you could do that.
Okay, all right, that's all I need to know. Thanks. All right, you have a good night.
Good night.
Professor, I have a question.
Go ahead, please.
So if we can't figure out exploit by Thursday when we have class, are you going to push back the homework or just take off exploit from the homework?
Yeah, so it would be just 5. I'm hoping that it'll be figured out by Thursday. Okay, so I mean, it's gotta be something pretty simple. I can't imagine that exploits don't work anymore. You know what I mean?
Yeah.
So that's why I was playing around with that hex encoding. I feel that the issue is around the hex encoding.